This is a review on solving quadratic equations using the quadratic formula. So remember, a quadratic equation has this form. So let me go ahead and actually put this here. So it has this form, ax squared plus bx plus c equals 0. And so what makes it quadratic, remember, is the largest exponent is 2. So um, that it makes this a quadratic equation. So you have this exponent here, that's 2, this exponent, that's 1, and then your constant. All right. Now, you can solve all quadratic equations. Every quadratic equations you can solve using the quadratic formula. And so the quadratic formula is this. It's the opposite of b plus or minus the square root of b squared minus 4ac. And this b squared minus 4ac, that radicand, that's called the discriminant. So the discriminant, when you talk about that a little bit more in future lessons or next semester, is a way to determine what kind of solutions you're going to end up having. And all that's being divided by 2a. Now, the letters b, a, and c all come from these coefficients here. So a is a coefficient of x squared, b is a coefficient of x, and c is your constant. Now, before you use a quadratic formula, it's very important that you see that 0 must be on this side, or 0 must be on one side, either the left or the right, but you must have 0 in there. Okay? All right, so let's look at number 1. So number 1, let's suppose we have 12x squared plus 7x equal 12. All right, so 12x squared plus 7x equals 12. So notice this is a quadratic equation because you see that x squared there. But the problem is I can't use quadratic formula yet because I don't see that 0. So I need to bring this 12 over. So I get 12x squared plus 7x minus 12 equals 0. And it helps if you have it in descending order. So x squared, x, and then your constant. So that's descending order. Before you substitute these values into the formula, it helps if you write out what a, b, and c are. So a, remember, is the coefficient of x squared. So the coefficient of x squared is 12. B is a coefficient of x. So the coefficient of x is 7. C is your constant. Your constant here is a negative 12. Make sure you keep the signs correct. So if this was a negative 7, you would put a negative 7 here. If this was a negative 12, you put a negative 12 here. So C here is negative 12. Then we're going to use the quadratic formula, the opposite of b, plus or minus the square root of b squared minus 4ac. All of that's being divided by 2a. All right, so here's what you're going to write. So you're going to say x equal, the opposite, you read this as the opposite of b. Well, if b is a 7, the opposite of 7 is negative 7. Plus or minus the square root of b, notice I'm putting in the parentheses, b is 7 squared, minus 4 times a is 12, times c, which is negative 12, all divided by 2 times a, which is 12. So all I did was I substituted these values into the formula. Now the next thing you're going to do is you're going to simplify this radicand. So 7 times itself is 49, so I get negative 7 plus or minus the square root of 49. All right, now be careful here. Use your calculator if you have to. So first of all, notice that a negative times a positive times a negative is going to be a positive. And then 4 times 12, so that's 144 times 4 gives us 576. All right, all divided by 2 times 12 is 24. All right, now let's go ahead and add these two numbers together. So I get negative 7 plus or minus, all right, 49, I'm using my calculator, 49 plus 576 equals 625 divided by 24. Now at this point what I would do is I would ask myself, is this radicand a perfect square? And so one way to do that is to take the square root of 625, see what you get. So notice the square root of 625, make sure you know how to use your calculator. So square root 625 press equal, that's 25. So 625 is a perfect square. The square root of 625 is 25. So what I have here is this, negative 7 plus or minus 25 divided by 24. Just like in a previous topic when we talked about the square root not appearing any longer, notice the solutions here, since there's no square roots, the solutions here are going to be rational solutions. It's going to be rational solutions. Since those are rational solutions, you want to write them differently than if they were irrational or complex. So you're going to break this apart. So you're going to say negative 7 plus 25 divided by 24, comma, negative 7 minus 25 divided by 24. So negative 7 plus 25, negative 7 minus 25. Then let's go ahead and simplify the numerator. Negative 7 plus 25 is 18 divided by 24, right? Oops, not 18. Let's say 25 minus 7. Yep, 18. All right, 18 divided by 24, right? And then I can reduce this, correct? So they're both divisible by 6. So reduce if you can. 18 divided by 6 is 3. 24 divided by 6 is 4. So you get 3/4. So there's one of your rational solutions. 3/4 is a rational number. Over here, negative 25 plus a negative 7. Negative 25 plus a negative 7 is a negative 32 divided by 24. Those are both divisible by 8. So negative 32 divided by 8 is a negative 4. 24 divided by 8 is 3. So there's your two rational solutions. So I solved this quadratic equation using a quadratic formula. And notice the process. Again, notice that since these are going to be rational solutions, you actually you wrote out separately what your solutions are. All right, that was number 1. Number 2. Let's suppose we had this in number 2. We had x squared minus 8x plus 25 equals 0. So remember the direction says you must use the quadratic formula. Notice that this is already in standard form. I see that 0. So I'm going to go ahead and denote a, b, and c. So a is a coefficient of x squared. Well, x squared, that coefficient right here is 1. b is a coefficient of x, so that's a negative 8. c is your constant, so that's 25. And so now, remember the quadratic form is negative b plus and minus the square root of b squared minus 4ac, all divided by 2a. So I'm going to go ahead now and substitute these values in here. So I get the opposite of b, so x equals the opposite of b. So the opposite of a negative 8 is a positive 8. Plus and minus the square root of b, which is a negative 8 squared. Notice I'm squaring that negative 8. It must be put in parentheses because remember a negative number squared is positive. So you've got to be careful. B squared here is positive. Minus 4 times a, which is 1, times c, which is 25. All divided by 2 times 1. So I get 8 plus and minus the square root of 64. Negative 8 times itself is 64. A negative 4 times 1 times 25 is a negative 100 divided by 2. 2 times 1 is 2. So I get 8 plus and minus the square root of 64 minus 100 is a negative 36 divided by 2. Now remember, you're taking the square root of a negative number, right? So remember, the square root of a negative 1 is defined to be I. So you see that square root of negative 36? The square root of a negative 36? That's defined to be the square root of a negative 1 times the square root of 36. Well, the square root of negative 1 is I. And the square root of 36, 36 is a perfect square. The square root of 36 is 6, so that's just 6i. So this right here becomes 8 plus and minus 6i divided by 2. Now, you need to recognize that all these numbers here, 8, 6, and 2, are all divisible by 2. So what some students will do when they see this, they'll say 8 divided by 2 plus and minus 6i divided by 2, and 8 divided by 2 is 4, 6 divided by 2 is 3. So you get 4 plus and minus 3i. Now be careful, don't say this is 7i, because that's not 7i, because that's not an I here. Those are not like terms, so you must write it like this. Now you can write it separately though. You can say two separate solutions. You could say 4 plus 3i, comma, 4 minus 3i. Does not matter. But the point also here is that your solutions are imaginary, complex imaginary solutions. Solutions are complex, imaginary, because of that I, solutions. Okay, in the previous one, they were rational solutions. Here, they're imaginary solutions. And usually they'll just say complex, but these are, remember, a complex number are real and imaginary. So keep that in mind. Um, but but usually they'll say complex solutions when in fact it's really complex imaginary solutions. All right, that was number two. Let's look at number three. In number three, we have this. In number three, all right, we have negative 3x squared plus 8x equal 9. Okay, now what some students will do in this case is they'll bring the 9 over, and which is fine because you before using a quadratic form you need that 0 there. So they'll say 3x squared plus 8x minus 9 equals 0. And then they'll go ahead and denote the a, b, and the c. So a here is negative 3, coefficient of x squared. B is a positive 8, and c is your constant, which is negative 9. I want you to notice, though, that there are some other students that will bring these terms to the other side. In that case, a, b, and c are opposites, but you'll get the same answer. Your solutions are the same. The solutions are the same whether you bring the term to the left-hand side or you bring all the terms to the right-hand side. This equation will have the same solutions. All right, so just keep that in mind. All right, using a quadratic form, remember the quadratic form is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so when you substitute, you have the opposite of b, which is going to be, if b is 8, the opposite of b is negative 8. So x equal negative 8 plus or minus the square root of b, which is 8 squared, minus 4 times a, which is negative 3, times c, which is negative 9, all divided by 2 times a, which is negative 3. Simplifying the radicand, I get negative 8 plus or minus the square root of 8 squared, 64. A negative 4 times a negative 3 times a negative 9. So negative times a negative times a negative is a negative. So 4 times 3 is 12. And so 12 times 9 gives us 108. So I get 108 here. All divided by 2 times negative 3 is negative 6. So 64 minus 108, 64 minus 108 equals 44. Sorry, right here. 64 minus 108 equals negative 44. So I get negative 8 plus or minus the square root of a negative 44 divided by negative 6. Okay? All right, now what I have now, see this square root of a negative number, so I'm going to get these imaginary numbers again. So remember the square root of a negative 1 is defined to be I. Also notice that the square root of 44, I can simplify. The largest perfect square that goes into 44 is 4. So it'll be the square root of 4 times the square root of 11. And the square root of 4 you know is 2. So you get 2 square root of 11. So this becomes negative 8 plus or minus. Now be careful how you write this. So notice, see this negative square root of a negative 44? That's the square root of a negative 1 times the square root of 44. So you get this I here. The square root of 44 is 2 square root of 11. And the way we tend to write this is we tend to put the I between the 2 and the square root of 11. Like this. That's fine. Leave it like that. Alright, so this becomes 2I square root of 11. All divided by negative 6. Alright. Now, there are multiple ways of writing your answer. Normally, though, in math, when you're able to simplify, you simplify. So see this negative 8, this 2, and this negative 6, they're all divisible by 2. Okay? So since they're all divisible by 2, this becomes negative 8 divided by 2 is negative 4, plus or minus 2 divided by 2 is 1, so that is I square root of 11, divided by negative 6 divided by 2 is negative 3. Okay? So that would be one of the possible solutions. Now notice though there are two, right? Because you see that plus or minus. But these are complex imaginary solutions because of that I, complex imaginary solutions. But remember that negative in the denominator? So So if this were multiple choice, you would probably not see that negative down there. So remember, a negative divided by negative is a positive, and then plus or minus divided by negative is plus or minus. So you can say 4 plus or minus I square root of 11 divided by 3. So these are equivalent. See, negative divided by negative is a positive, right? Plus or minus divided by negative is plus or minus. All right, now if you want to write them separately, you can. So you could say 4 plus I square root of 11 divided by 3, comma, 4 minus I square root of 11 divided by 3. Okay, so that was number 3. So sometimes it could be a little bit more complicated. See how much work we had to do here? So to simplify, and don't forget, if all these numbers here, this number, this number, and this number are divisible, they have a greatest common factor, then you want to go ahead and reduce it, just like we did here. All right, so just keep that in mind. All right, number 4. Let's look at number 4. So number 4, let's suppose we had 3x squared minus 8x minus 10 equals 0. All right, so notice that I already have 0 here. So a is the coefficient of x squared, so that's 3. B is coefficient of x, that's negative 8. And c is your constant, which is negative 10. So the quadratic form is negative b plus and minus the square root of b squared minus 4ac, all divided by 2a. So the opposite of b, so this is negative 8. The opposite of negative 8 is 8. So I get x equal 8 plus and minus the square root of b, which is negative 8 squared. Put that in parentheses because that's going to be a positive 64, not negative, minus 4 times a, which is 3, times c, which is negative 10, all divided by 2 times a, which is 3. So all you did was you took these numbers, substituted into this quadratic formula. So I got 8 plus or minus the square root of negative 8 times itself is 64. A negative times a positive times a negative is a positive. 4 times 3 times 10, use your calculator if you have to. 4 times 3 is 12. 12 times 10 is 120. All divided by 2 times 3 is 6. Now 64 plus 120 is going to give us 184 divided by 6. All right, let's talk about this 184. Let's see if we can simplify this, square root of 184. So think about the largest perfect square that goes into 184. So let's try 4. 184 divided by 4. I get 46. All right. Now, is there a perfect square other than 1 that goes into 46? Let me just divide. Although 2 is not a perfect square, let's see what we get when divide by 2. So notice that 2 and 23 are both prime. So that's not going to, so 46, the only perfect square that goes into 46 is 1. So what I found earlier about 4 being the largest is the largest. So the square root of 184 I can write as the square root of 4 times the square root of 46. And the square root of 4 is 2, so you get 2 square root of 46. So that's going to go here. So watch what happens now. 8 plus or minus 2 square root of 46 divided by 6. Now you see how I still have that square root of that square root symbol here. 184 was not a perfect square. So here I'm going to get irrational solutions. So these are irrational solutions. But notice that 8, 2, and 6 are all divisible by 2. So let's go ahead and simplify this. So 8 divided by 2 is 4. 2 divided by 2 is 1. So that's just the square root of 46. And then 6 divided by 2 is 3. And that's it. Now if you want to write them separately as two separate solutions, you can. You could say 4 plus the square root of 46 divided by 3, comma, 4 minus the square root of 46 divided by 3. All right, so those are your two solutions. All right, so that was number 4. Okay, let's look at number 5. So number 5, we have 3n squared equal 5n minus 1. Now notice that your variables are not always x. You could have different variables here. So just make sure if the variable's in, you're using n throughout your process. So I have this quadratic equation. If I'm going to use quadratic formula, I need to make sure that all the terms are on one side. So I'm going to subtract 5n from both sides first, right? So I get 3n squared minus 5n equal negative 1. Then I'm going to add 1 to both sides. So I get 3n squared minus 5n plus 1 equals 0. All right, it's in descending order. So a is a coefficient of n squared, so that's 3. B is a coefficient of n, so that's negative 5. And C is your constant, which is 1. So using a quadratic formula, the opposite of b plus and minus the square root of b squared minus 4ac, all divided by 2a, here's what I get. The opposite of b, so b is negative 5, the opposite of negative 5 is 5. So I get n equal, see that n? N equal, because that's my variable, n equal 5 plus and minus the square root of negative 5 squared. See that's in parentheses. A negative 5 times itself is a positive 25, so don't say that's negative 25. Minus 4 times a, which is 3, times c, which is 1, all divided by 2 times a. And a is 3. Simplifying the radicand, I get 5 plus and minus the square root of negative 5 squared is 25. A negative 4 times 3 times 1 is a negative 12, all divided by 6. 25 minus 12 is 13, so it becomes 5 plus and minus the square root of 13 divided by 6. Now notice the square root of 13 cannot be simplified, so there's your answer. So those are your solutions. So you can say that, or you can write them separately. You could say 5 plus the square root of 13 divided by 6, comma, 5 minus the square root of 13 divided by 6. All right, so those are your two solutions, either this way or that way. All right, so that's number 5. Okay, let's look at number 6. In number 6, let's suppose we had 2x squared minus 3x minus 2 equals 0. All right, and so notice it's already in standard form. It's already in descending order. So let's denote A, B, and C. A is 2, B is negative 3, C is negative 2. So quadratic formula, negative b plus and minus the square root of b squared minus 4ac, all divided by 2a. All right, substituting to the formula, I get x equal the opposite of b, so the opposite of negative 3 is 3, plus and minus the square root of b, which is negative 3 in parentheses squared, because negative 3 times itself is going to be positive 9 in this case, minus 4 times a, which is 2, times c, which is negative 2, all divided by 2 times a, and so that's 2 times 2. Simplifying the radicand, I get 3 plus and minus the square root of negative 3 times itself is a positive 9, so b squared can never be negative. It can be 0 or positive, but never negative. So in this case, it's positive 9. A negative 4 times 2 times a negative 2 is a positive 16, all divided by 4. So I get 3 plus and minus the square root of 16 plus 9 is 25, divided by 4. The square root of 25 is 5, so I get 3 plus and minus 5 divided by 4, right? Then notice that the square root of 25 is a perfect square, so I end up with 2 rational solutions. I'm going to get 2 rational solutions because I don't see a square root anymore. 2 rational solutions. So since I'm going to get 2 rational solutions, let's break it apart. So you can get 3 plus 5 divided by 4, 3 minus 5 divided by 4. 3 plus 5 is 8, so I get 8/4, which is 2. So there's one of your solutions. Over here, I get 3 minus 5 is a negative 2 divided by 4, so I get negative 1/2. So there's the other solution. So your two solutions are 2 and a negative 1/2. Okay? All right, that was number 6. And let me just kind of show you one more. So this is number 7. Number 7, let's suppose we had 3x squared minus 4x equals 0. All right. Now, again, notice it did say use a quadratic formula. So you must use a quadratic formula. But here, it's so much easier, since there's no constant, to factor out an x. And then you could set each one equal to 0. Meaning that if you factor out an x, you get x times 3x minus 4 equals 0. Then you set each factor equal to 0, so you get x to be 0. 3x minus 4 equals 0. So here, one of your solutions is 0 because x is already by itself. Over here, 3x equals 4, so x is 4/3. So those are your two solutions. But remember, the directions said use the quadratic formula, so you must use the quadratic formula. Follow directions. If you do this problem and the directions said using quadratic formula, if you do it this way, you're not following directions, so you don't get any points. All right, so follow directions. So let's use quadratic formula. So a is 3, b is negative 4, c, your constant's 0. So C is 0 in this case. So quadratic formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So I get the opposite of b, so the opposite of negative 4 is a positive 4, plus or minus the square root of negative 4b squared, negative 4 squared, minus 4 times a, which is 3, times c, which is 0, see that's 0 right there, all divided by 2 times a, which is 3. So you get 4 plus or minus the square root of negative 4 times itself is 16. A negative 4 times 3 times 0 is 0. So you can say plus 0 minus 0, but it doesn't matter because that radicand is just 16, isn't it? All divided by 6. 2 times 3 is 6. So you get 4 plus or minus the square root of 16 divided by 6. Now notice the square root of 16 is 4. So this becomes 4 plus or minus 4 divided by 6. So you see, you no longer have that square root, so these are rational solutions. Rational solutions. So in that way, you break it apart. You get 4 plus 4 divided by 6. You get 4 minus 4 divided by 6. 4 plus 4 is 8, so you get 8 divided by 6. Reduced is 4 thirds, which is what you saw here. All right, so there's one of your solutions. Over here, 4 minus 4 is 0. 0 divided by 6 is 0, which is the other one, and that's what you saw here. Okay, so remember, this is what you had to do. This is using factoring. All right, that's using factoring here. But that was not the direction. The direction said use quadratic formula, so make sure you always follow directions. And I brought that up for several reasons. Some students don't know what to put for C, so C is 0. The other is that when they see this, they recognize, hey, I can do this by factoring, so I'm going to use factoring. But you're not following directions. Always make sure you're following directions. All right. So that is a review on solving quadratic equations using the quadratic formula.